Hello everyone, hope you all are doing well. So now we will do this one topic, that is effect of change in temperature by chemical reaction. Last time we have done the concentration, but now we are doing its temperature effect. In temperature effect, we are having exothermic equilibrium and endothermic equilibrium. In endothermic equilibrium, we are just resembling it with delta H, and in exothermic we are resembling it with minus delta H. Okay, let's take an example. Here we are having 3H2 plus N2, and here we are having 2NH3, that is ammonia, and we are having heat in product that represented by negative delta H. Now it shows that delta H in negative, the reaction in exothermic in the forward direction. Like when this heat in a product goes to the ammonia, this ammonia do the backward reaction, that is a reversible reaction towards the reactant. Here is that if we increase the temperature of equilibrium system, like we increase the temperature of equilibrium system by providing some heat to them, so then it effect on product, like the heat effect on product. Okay, and it's shift to the left side. This is the right side, this is the left side. So the that shift to the left side. Okay, and it will call the backward reaction. Okay, here that if we increase the temperature, here two properties, that first of all, if we increase the temperature, so it's the backward reaction. If we decrease the temperature, so it's the forward reaction. Like increasing in temperature is backward reaction, decreasing in temperature is forward reaction. Okay, now let's move to the endothermic. Here is an example of endothermic. In endothermic we are having heat, but in the form of reactant. In reactant we are having heat. If we increase the heat by higher in temperature, so system shift from left to right to produce more 2HI product. Like if we are having more heat, like we are having some of heat with the respect to higher in temperature, so what it will do, it will go in reactant, and there will be the more reaction in product. It will make more products. Okay, it will make more 2HI. So this reaction will be the forward reaction. So here is a there are two properties of this. One is increase in temperature is a forward reaction. Like if we are increasing the temperature of exothermic, endothermic, so there is the forward reaction. Okay, but when we are decreasing the temperature, so here will be the backward reaction. But remember that in exothermic, if we are increasing the temperature, so it's a backward reaction. Okay, not forward reaction. And if we are decreasing the temperature, so we are having forward reaction. It's a vice versa totally to each other. Okay, let's move to another. Here we are having effect of change in pressure or volume. How we are changing a pressure or volume, how it affect on a chemical reaction. Like here I have written a statement that all reacting species are gaseous state, where the number of moles of reactant gases, okay, are totally different from the number of moles of products. Okay, so it will be delta n number of moles is not equal to 0. Okay, referring to the ideal gas law that we have done in our previous lectures, that is PV is equal to nRT. The pressure applied to the system is directly proportional to the concentration of reactants. Like when we are just applying the pressure on the system, it's directly proportional to the concentration of reactant and inversely proportional to its volume, but at given temperature. What? At given temperature. Okay, now let's move towards that. If pressure is increasing, the quantity with less pressure affected. If we are increasing the pressure, so the quantity will be the less pressure affected. Like here we are having the example, that is 3H2 plus N2, and it form that 2NH3. Here we are having volume, that is 4, and here we are having volume, that is 2. Reactant having more volume and product having less volume. So because of more volume, there will be the less pressure, and because of less volume there will be the more pressure. Like it's also totally vice versa to each other, that if we are having more volume so less pressure, if we are having less pressure so we are having more volume. Okay, now let's move further. Hence, more pressure are on reactant side is acquired. Like we are having more pressure on reactant side. Acquired means it have on reactant side. Okay. Then product of pressure of reactant is greater than pressure of product. Okay, due to which pressure flow from higher pressure to lower pressure. Like we are having more pressure on this one side reactant, so obviously there is a less pressure in product, so it moves towards the lower pressure, higher pressure toward lower pressure. It means that reactant move towards the product, and this reaction is called the forward reaction axis. Now let's move to the backward reaction axis. Here, if pressure is decreased, reactant side is not affected. Like there was pressure increasing. Pressure was increasing over there, so we are having affecting in reactant. But if the pressure is decreasing, we are having no any effect on the reactant, because pressure on reactant is very small, is in very little amount. So while pressure on product side is affected, means higher. Like obviously the pressure on the product side will be affected because there is a higher pressure over there, so due to which product pressure is decreased. Like in that, in upper one situation we are having more reactant, so we are moving from higher pressure to lower pressure, means from reactant to product. But now product have a more pressure, so we will move from more pressure to low pressure. So we are having more pressure in product and less pressure in reactant, so we will move in the backward direction or backward reaction axis. So just we have to remember the main points, that in effect of change in pressure or volume, if we are increasing more volume, so there will be the less pressure. If there will be the less volume, so there will be more pressure. And one more thing, on which side we are having a more pressure, we have to check it out, and then we have to tell that it's a backward reaction or the forward reaction. If we are having pressure of reactant greater than pressure of product, so this is the forward reaction. If we are having pressure of reactant less than pressure of product, so it's called the backward reaction axis. And in effective change in temperature, it was same, that there are two main parts, one is exothermic and second is endothermic. Hope you understand these both and their properties too. Thank you so much for listening. If you have any question, you can write your question in comment. I will reply you as soon as possible. Till that, Allah Hafiz.